Welcome, everyone. It's a little early here in Porto today, but it is such a gorgeous day. I have so much fun looking out across the bay. It's such a gorgeous city. Welcome to Minimal APIs with ASP.NET 6. We're going to live code everything, upgrading a project from .NET 5 to .NET 6, and get to see a lot of C# 10 features in addition to minimal APIs. Here's the part where I tell you I am definitely going to post the slides on my site tonight, but in this talk, there are no slides. That's it. Notepad. But what's really cool is the code that we're going to build today is up online on GitHub right now. So you can go to github.com/robrich/minimal APIs ASP.NET 6. Let's head to robrich.org, and you can click on presentations here at the top. And here's minimal APIs, and so you can get to the code a lot easier. robrich.org will get you straight there. While we're here on robrich.org, let's click on About Me and see some of the things that I've done recently. I'm a Jetpack developer advocate. If you're struggling to deploy your microservices to Kubernetes, I would love to learn from you. Some of the other things that I've done, I'm a Microsoft MVP, MCT, Docker captain, friend of Redgate. AZGiveCamp is really fun. AZGiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZGiveCamp. Or if you'd like a give camp here in Porto or wherever you traveled from, hit me up on email or Twitter or see me here at the conference, and let's get a give camp in your neighborhood too. Some of the other things that I've done, Pro Microservices with .NET 6. That was fun. I got to work with Matt and Sean on that book, and so you can grab that. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's take a look through this project. Each of these folders are one of the steps that we'll go to today. Let's start with this bare minimum project. So I'm going to come in here. I have one file, just a CS_proj file. Let's open that up in VS Code. And here's the CS_proj file, not that much to it. You know, it basically says we're in .NET 6. I'm going to create a new file. I'll call this program.cs. And let's create a C# 10 ASP.NET 6 project. Var builder equals web application builder. Is it builder? Here's the part where I go reach into my notes. Web application.create builder. Ooh, yes, let's create that .vs code folder. Web application.create builder. And then I will say builder or var app equals builder.build app.run. And let's also say app.mapGet. I will map the home page to this function, which will return a new object. Let's say message equals hello world, but hello world is a little boring. So let's also say, let's take in a string name and we'll make that optional. And we'll use that here. So let's say name, or if you don't give me one, world. Okay, 4 lines. That's pretty cool. Let's come in here and let's say .NET run and fire up our web server. Now, this will take just a minute to compile because, of course, my machine just woke up this morning. But now we've got a website. Let's go to that website. And we have our content. Hello, world. Now, the cool part about this is that we can also do things like, let's say, name equals NDC Porto. And now we say, hello, NDC Porto. If we fire up the Chrome developer tools and take a look at the network, let's refresh this page. We can see that we have the correct HTTP status code. It's 200. We have application JSON. we grabbed query strings, we rendered content. We just built a entire ASP.NET website in 4 lines of code. That's pretty cool. But that's kind of a lot. You know, remember the visual Fred thing where we're like, but that doesn't look like the code that I write. So that's definitely possible. But let's step back and take a look at the content that we've got. Now, I'm going to start with an ASP.NET 5 project here. This ASP.NET 5 project, let's fire it up. This uses C#9, ASP.NET 5. So this is, oh, I do need to refresh my certificate. That's cool. Okay, so now we've got, let's close this. Start that back up. There we go. So now we have this, oh, I need to stop the other website. When trying to run the other website, yes, of course that port is already in use. Let's try that again. There we go. So here's a website that we just built. Now this is an ASP.NET 5 website, but this uses some interesting things. We have a home page, a privacy page. Both of these use MVC. We also have Razor pages. Here's an about page running Razor pages. We also have a web API, so here's some weather forecast details. And of course, because we have a web API, we have Swagger in here, Open API. So let's fire that up and we can execute it and we get some weather information. Now that's pretty cool. We have this website that has all of these technologies running together. How did we do that? Well, let's hit stop here and let's wander through it. We have these controllers. Here's our MVC controller, and it's going to return a view. And to rig that up here in startup.cs, we said we want to add controllers with views. And down here, we said we wanted to map controller route, given our default route. But we also have Razor pages here. Here's our about page that's a Razor page. It's just a page. How did we do that? Here in startup.cs, we said I want to add Razor pages. They aren't mutually exclusive. It's just the templates don't put them both in place. And so we have our Razor pages. Here's our Razor page master layout, which is pretty cool, our main layout. And we also have web API, which in this case, it's a controller. So we have our standard one that will go grab us 5 random weather pieces. And we did that because, of course, we, not in program, in startup, we said add controllers. Now we did rig up Swagger. So here's the add Swagger gen piece and the use Swagger and Swagger UI. So we have the 3 paradigms inside of ASP.NET. We have MVC, we have web API, and we have Razor pages. They can all run simultaneously inside the same site if we rig up those pieces inside of our request pipeline. So now that we've got our .NET 5 app, let's move this to .NET 6. Now I could definitely come in here to this and say properties, but I'm just going to dig into the file itself. And let's change this from .NET 5 to .NET 6. We just upgraded our project to ASP.NET 6. Thanks for coming. No, I'm just kidding. So we just did that. Let's see if we have any NuGet package updates. Yep, it looks like we can update Swashbuckle. So let's update that one. Let's presume Wi-Fi works as expected. Looks like that's going to work. Yes. So now we can fire our website up. And now we're running in ASP.NET 6. All we did was change the version from 5 to 6, and we'll probably see significant performance improvements just because .NET 6 is faster. They did a lot of work with span of T. They did a lot of work with making this site optimized just to make the runtime faster. So we've got our site now in ASP.NET 6. Here's our MVC, home and privacy pages. Here's our Razor pages about page. Here's our weather forecast controller. We've got some values. So we just moved from .NET 5 to .NET 6. And if that's the only part that you want to do, you're going to see performance improvements, and that's all you need to do. That's really cool. But of course, we want to go a little bit farther. So we just upgraded from .NET 5 to .NET 6. Now let's take a look at namespaces. New in C# 10, we can use file scoped namespaces. Now the old syntax still works, so if I have more than one namespace in a particular file, I can do it this way. But I've indented 4 spaces for my class, I've indented 4 more spaces for my method, I've indented 4 more spaces to start my method. I'm at 12 spaces in and I haven't even done anything. Can we remove some of the ceremony? Let's do that. Now I love that refactoring in Visual Studio where it automatically does all the things. This is a file scoped namespace. Now the cool part about this is this namespace now applies to the entire file. Now if I do have 2 pieces in my website or in my class file, hey, that was cool. If I do have 2 pieces inside my class file that need different namespaces, then, I'm actually going to throw that because it's going to fall down again. If I do have 2 different sections in my file that need different namespaces, I can use the old syntax because this applies to the entire file. But in this case, the entire file is one namespace, so let's do that. Let's come in here as well and update this one, and we'll come in here, there's a C# file there, and let's come in here, we've got some models, let's do that as well. Inside program.cs, let's do that. Startup.cs, let's do that one. Weather forecast, let's do that one. Save all those. Let's go find namespace. And it looks like we did it. We moved all of those things to the namespaces. Any questions so far on moving from .NET 5 to .NET 6 or file scope namespaces? Excellent. Now we can build this, and if we just build, then it's gonna do just fine. And now we have only 8 indents into our method. So, here's our methods and 8 spaces. That's pretty cool. Nice improvement there. So we're able to use global usings, and that's this section right here. Let's take a look next at implicit usings. So I'm going to come in here to my site, and I'm going to say implicit usings enable. And I will indent that 2 spaces. There we go. So we've now said there's a bunch of namespaces that probably get added to every project. Now we have here, for example, system. In here we have link and threading tasks and a bunch of other namespaces that will probably include in every file in an ASP.NET project. So what we get with implicit usings is because we're looking at this particular SDK, then we can probably make some assumptions like you probably want system.link, system threading task in all of the places. Let's build this again and then go wander into our project. Let's go look at the obj folder, into debug, into .NET 6, and here we have site.globalusings.g.cs. Because I turned on global usings, all of these usings got added automatically. Oh, I jumped ahead a step. Let's centralize our usings, and then we'll come back to global usings. So I'm going to take that out for a second. I'm going to come in here to program.cs, and we have using system. We probably put that at the top of every file. Let's say I want to do that once for my entire project. I can say global using system. Now the cool part is because I've said global here, it's going to apply to every file in my project. So I no longer need this using system statement at the top of this file, and it will still compile correctly. This global using says that we can centralize our usings in one place. So there is no official convention for this, but I'm going to add a new file, and I'm going to call this global.cs. It's a class. Now here in global.cs, I'm just going to take all of my usings and move them into one place. So let's go grab all these usings, and we'll put them here. And I'll go grab all these usings, and I'll put them here. And I'll go grab all of these usings, and these usings, and I already grabbed those ones. Let's go grab these usings, and we'll go grab these usings. And I'm going to remove this one global thing, and let's do a regular expression. I'm going to search for the beginning of the line and replace that with global. So now we've moved all of our using statements into this one file. Now we do have some duplicates. I love the green squiggles here inside Visual Studio that allow me to say, hey, let's remove all of those duplicates. Here's some more duplicates right there. Here's some duplicates there. There's some more duplicates. Okay, so now we have all of our using statements in one spot. Let's go find using and make sure I got them all. Yes. Okay, so now because we have all of our using statements here in one file, then at the top of, say, startup.cs, I don't need to fight over adding the using or removing it. Should you, you know, all the merge conflicts that we get trying to get the top of the file to exactly match? All of that is gone. We moved that to one file. Now the cool part here is if we needed to specify a specific using that may only apply to one file, we can definitely use the other syntax without the global in front of it. And that might be helpful if we need to disambiguate something that, you know, maybe we have two classes that have the same name in different namespaces. We can do that inside of a particular file. But I love that I've kind of centralized these usings into one spot here. But there are some redundancies here, like, you know, system link, system threading task. We might have those in every project everywhere. So returning back to our thing, we can say, let's come into site.cs proj, and let's enable implicit usings. And if we rebuild this project and wander in there, here's global usings.g.cs. Now this file is automatically generated for us based on our SDK choice, and it lists all of the using statements that we just get by default, which is excellent. So I'm going to take all of these global usings and I will temporarily put them at the top of this file, just so I get those green squiggles to tell me which ones are duplicated. And now I can remove all of these, and I can remove all of these, and now I'll pull this back out. And now we've simplified it down to just the using statements that we need, and our build still succeeds. That's really cool. All of the noise of all those using statements just kind of faded away now. If ever we have a need to add more usings, we can put them inside a file like this global.cs, and now they're all there in one place. Now we could definitely put this inside of a regular code file. We don't need to centralize it. Global.cs isn't any magic word. It's just I chose to put it there. Any questions so far about using statements and global usings? Cool. Well, let's dive in. So we did that one. Global usings, implicit global usings. Now let's take advantage of the new builder. So here in program.cs, we have a create host builder, which is over here. And then we have a .build, a .run. We have this startup file. There's kind of a lot of layers of indirection. If we're just getting started with .NET and we want to pull in a new project, we have a lot of files. So let's instead use this new builder. And so let's say var builder equals web application dot create builder. And then we can say builder dot build. That's var app. And we can say app dot run. Now we haven't rigged up our request pipeline yet. All of that is inside startup.cs. So let's go say var startup equals new startup. And startup takes in this iConfiguration. So let's pass in a builder.configuration. Now we need to kick off our dependency injection thing. So let's say startup.configure services. And that takes in a iService collection. So let's say builder.services. Now we still need to, that's our setup IOC. Now we need to still set up our request pipeline. So let's say startup.configure. And that takes in our app. Good thing we've got that right there. And app.environment to pass in our environment. And now we've got a website ready to go. Now, in this case, we still have our content off in that startup.cs file. We could definitely do that, but we can also take advantage of an interesting thing here for our startup file only, our program.cs, where we don't have a namespace, we don't have a class, we don't have a method. All of that is kind of generated behind the scenes. Now, we do need a using statement here, it looks like, using site. So let's go back to our global.cs and say global using site. And now that will take care of this as well. So if we like the startup.cs separation, we can definitely continue using that. But I kind of want to flatten this out so I don't have this other section. So I'm going to take this and let's move that into place right here. Now we have this services, so let's swap that out with builder.services. Grab that here and here and here. There's a way to shrink this. I think it's like that, but I've gotten it wrong before, so I'll just leave that. Let's go back into startup and let's go grab the request pipeline details and we can move that into place. Let's grab that and set it right here. And now because we're using this, we can't use env. We could definitely say something like var env equals app.environment, and that would get that variable into place, but I'll just use it directly. So we'll say app.environment, and we can also simplify this a little bit. Instead of using endpoints, we can just use our app and get that content into place. Now that looks so weird. It's cool, but it's like, where's my static void main? Where's my program.cs? For only this class, C#10 will just go, I think I can figure this out for you. And so it'll wrap it in a program.cs, it'll wrap it in a public static void main, and we'll get that content into place. So if we build this, we could run it and we can see our site is still running. Now in this case, we'll just say build succeeded and we're ready to go. So we don't need our startup.cs anymore. Let's just delete this file completely. And now we're able to use that new builder. That's pretty cool. Now our builder still does the same things. So we still have this section where we rig up dependency injection, and we still have this section where we rig up our request pipeline. So that's this one. Now let's dig into minimal APIs. This is fun. So right now we have ASP.NET MVC, we have WebAPI, and we have Razor Pages. Razor Pages is good for, I like the term brochureware, a static website where we just need to be able to host some stuff, but we may not have a whole lot of business logic behind it. MVC is great when we need to upgrade to have more content, layers of indirection. We now have controllers that we can separate, views, we can render a different view based on details within our application. And we can use WebAPI where we just spit out JSON or XML instead of views, Razor views. And now we have a fourth paradigm here that is minimal APIs. So let's say app.map.get. Now I want to map API/minimal, and I want to do something with that. So here's my method, and I'll return a new object. And here inside my object, I will say message equals hello world, and ID equals 3. Now I'll do this a little bit more dynamically because that was pretty cool last time. Let's say we'll grab a particular name, not name of, name. And if you don't pass one, I'll pass in world. So let's take in a string name. I'll make that optional. And if we want to, we can optionally say from query. I could also say from body or from headers, or, I can attribute it with its source so that I'm very specific about where it came from. Now that's really cool. We just grabbed a query string parameter, this name, and we rendered this new object, and all of that is kind of in line. If you've ever used Node and Express, this feels right at home. I just give it a URL, I give it a method to do stuff, and away it goes. That's cool. Now we did this with map.get. Let's also do an app.map.post. Now in this case, I want to grab some query parameters. So let's say, or URL parameters. Let's say API/minimal/1 and 2. And now with those, I will have my method. And now I'm going to take in a string 1 and an int 2, and it will automatically map those route values into my parameters inside of our method. So let's do a similar thing where we just return that new message. But in this case, instead of hello world, I will say this is 1 and my ID is 2. Cool. Now we just did a map post. Now let's do a similar thing if we wanted to do a little bit more logic. Let's say app map put. So I'm going to say API minimal, and maybe I'm saving a new one. So in my parameters, I want to say, let's take in a int ID, or actually we're creating a new one. So let's say object data, and I want to return a new thing. So let's say the message is created, and the ID is 3, and the data is the data that we passed in. Now, that just kind of inlined that, but maybe I want to do a little bit more logic. So let's open this curly brace, and let's close this curly brace, and let's say return. Now, maybe I want to say if it exists if the saving worked, so let's say worked, then, or maybe let's say invalid. If it's invalid, then I want to return 400. So in MVC or in WebAPI, we would say this dot JSON or this dot not found, and this is not a base controller anymore. It's this method. So how do we return particular things? We have this class called results. And so I can say results.badRequest. And that returns the 400. So, oh, this one is returning a results and this one is not. So let's say return results.OK, and we'll pass in this as our body. And now we're returning a consistent type. There we go. So now we've got it returning a 400, or we've got it returning a 200 with this content. I could say not found for a 404, or I could even say status code and say 500 or 301, or my favorite, 418. HTTP status code 418 is actually really fun. It's I am a teapot. But in this case, I'll just say bad request. Cool. So if we need this kind of simpler user experience, we can just map the methods into place and do what we need to do. If we get to a certain level where we kind of need more structure, maybe we have 20 of these, 30 of these, or we want to have entity, maybe we have a rich entity diagram, so we have 8 or 10 classes and we want CRUD methods for each of them, then this may get pretty big. You know, we have 50 lines here in this one file. And we know the rule of thumb is you shouldn't have a code file bigger than your head. So let's see if we can add a little bit more structure to this. So I'm going to grab all of this code and let's create a new folder. I'm going to make a new folder and I'll just call this APIs. And I'll add a new file in this called minimal. And here inside public class minimal, I will have some methods. So let's create a method here and we will call this our get method and public object get. And so get will do that. And now let's have a post method. So let's grab this out and we'll say public object post. There's our post method. Maybe we need a, oh, yep, that was post. Here's a put method. So let's go grab this one and say public object put. And now, because we're building a real method, let's do that. I yanked out a curly brace there. Now it's a little bit happier. So now we probably have a more consistent thing. So let's create a new model here inside our models. Add new class. Let's call this a minimal model. And this has a public int ID. Get set will equal 3 just to give it a default value. We'll have a message, and that is set to a blank string because we're using nullable reference types, public minimal model data, and that one we will allow that to be nullable. And now we have this minimal model. So let's go back into our minimal class. And so now let's return this new minimal model. Message will now need to be capitalized. ID will be capitalized. Let's return that minimal model there. We'll return minimal model there. So let's create this new minimal model that has a message and an ID. Here we will return an I result. And ideally, I would like to say an I result of minimal model, but I don't think that's a thing. But here we will say a new minimal model, and we'll give it the message and the ID and the data. And so now I'll invent this thing, let's say public void init. And we'll take in a web application, an app, and let's do some initialization. So not that one, that one. So I'm going to say I want to map get to my get method and map post to my post method and map put to my put method, and now I have this initialization. Okay, I'm trying to gain more structure here. Oh, looks like I have a syntax error here. Data equals data. There we go. Oh, and that's a minimal model, not just an object. Okay, so we've got our minimal model here inside program.cs. We need to say var minimal equals, hey, we've got a dependency injection container. Let's say app.services.get required service of type minimal. And now that we have that, we can say minimal.init and app. And I just invented all of, oh, we need another using. Excellent. Global using here, site.apis. There we go. Now I just invented this minimal thing, but we kind of have a little bit more structure now. So we've kind of separated some of the pieces. Maybe our startup.cs is a little smaller. But if we look at this real close, it kind of looks like a controller. We've reached the point where the complexity in our application probably doesn't fit minimal APIs. It probably fits controllers. So I would argue that this was not a great idea, that we should have just flipped over to WebAPI. And with WebAPI, we have controllers and we can automatically discover them and everything is just fine. But that was interesting. We did add a little bit more structure to it. So now let's take a look at, actually, any questions so far on minimal APIs? Anything that I did here that was a little weird or that feels a little squishy? Yep. Inside my boot method, I have a typo on. Mini-YAML right there? Yeah, that would be very bad. Yeah, good catch. Thanks. That typo would have really bitten me because we're about to hit testing and that would have caught it. Good catch. So let's take a look at testing. How might we test this application? Now I could definitely say, let's go add another project and we could go reach into our projects and do that. But we've got the code right here. So let's open up the 9 folder here. We've just been working out of this 2 folder the whole time and that's been really fun. But let's flip over to the 9 folder, close solution. And let's open a project. Let's come here to 9, testing. Now this is cool. Let's build this. We've got our project. We did that minimal abomination thing that probably should be a controller. Apparently I spelled it correctly this time. We've got our controllers. We've got razor pages. We've got all of the content here that we had before. And then we also have this site.tests project. So here's site.tests. And that allows us to write some unit tests around these particular things. So for example, I have this weather forecast controller and I want to write a test around this weather forecast controller. Now it's going to grab random data, so I can't validate that it's going to render a particular temperature, but I know that it's going to render 5 of them. So let's create a unit test. Now we're going to use the same arrange, act, assert pattern that we see in lots of different frameworks. And I'm just going to create a new instance of this weather forecast controller passing in this logger. Now I did this logger with MOQ, with mock-u, that just allows me to make a mock logger of whatever. I could also notice here that I'm not using it. So I could probably just delete that dependency as well and make this test a little bit simpler. But okay, so I mocked this, I created an instance of this, and I'm just going to call the get method. Now this is a really straightforward unit test. We're just calling into that method and validating that we get the results. I love this assertion scope inside of Fluent Assertions that allows us to be able to run all of these assertions. If ever you've had a unit test where it's like, the first one failed, but I didn't run the other ones, So I fixed the first one, now I run the test again, and now the second one fails. I like this because it'll run all of the assertions and then fail the test. So I want to validate that my results are not null and that I have 5 results in that result count. Pretty straightforward unit test. Now on the upside, I'm able to validate my minimal API, or not my minimal API, my web API action. I call the action and I do all the things, but I haven't flexed the request pipeline. I don't have all the details of authentication and middlewares and all of the other pieces that might make this happen. So let's write an integration test into WebAPI. Now in the past, this was really painful, but here in ASP.NET 6, it is so nice. Now we have this Program.cs that we built over here, and we're just going to descend from that. We might pass in additional things. Here I'm passing in that builder and I could override services. Maybe I don't want to hit the real database. I want to hit an in-memory database or fake out particular repositories. But now I've just built up this fake app. Now it's going to run all of my pipelines, all of my middleware, but it doesn't need to find an available port. It doesn't need to pick a random port. It doesn't need to do things over HTTP. It does it over memory instead, which is excellent. Now, in my test, let's come back here. We just instantiate that object. Now, we could pass in a particular environment, but I'm good with development. Isn't that cool? This using statement that doesn't have curly braces. This using statement will just apply for the rest of the file. So I don't need to indent more. So I go grab an instance of this application, then I create client, which will create an HTTP client of this project, and then I can just fire requests at it like I would fire requests at anything with HTTP client. So I'm going to get async, the API weather forecast. I'm going to read that as a string. I'll deserialize that into a list of weather forecasts, making it nullable just in case. And then I'll go do those assertions. Now the difference between this and the unit test is that we're flexing the entire request pipeline. So middlewares, authorization, authentication, anything that we need to do will happen in this mechanism. Now the one piece that I glossed over right here is program. Now by default, we have this auto magically generated thing right here that we'll just kind of wrap it in a class called program and give it a static void main that does all the things, but it's private. And so how do we instantiate it over here? There's this trick. Now we can specify the other half of this auto-generated partial class. And so let's create this other half of the auto-generated partial class. And in this case, we will call it public. It feels so dirty to do that, but it so works. I'm reaching into that program.cs that is automatically generated and making it public so that then I can create this fixture with it, and therefore I can create this unit test around it. That is so much easier to do integration tests in ASP.NET 6. That is so cool. So now let's take this minimal API out for a test. We want to be able to hit the get request and do this get method. We want to post into these things. So let's do an integration test into this minimal API. Now we could have done this just with regular minimal APIs. You know, the whole abomination of refactoring it into a class was kind of interesting, but not necessary. So I'm going to create a new site, create my HTTP client from that site, and then fire a request at it, giving it a name of test. So I would expect the message to come back to say, hello, test. So let's deserialize that into the minimal model that we built here. And then let's go check to see it's not null. And then the ID should be 3 because remember I hard coded that to be 3 back then. And then the message should be hello test. Well, what if message was null? Would I get a null reference exception here? That's the beauty of minimal APIs is, not minimal APIs, but rather fluent assertions. It uses extension methods. And so this extension method oh, I can't download the source there. This extension method will, there we go. It takes in this string. So if this string happens to be null, that's fine. I don't get a null reference exception here. I just pass this null thing into should, and I just love how easily that renders, how easily it is to parse it. The model message should be hello test. That's really legible. That's really clean. Okay, so we have this get method that validates that if we pass in this query string, we'll get as expected. Let's run a unit test about post. So here's our post, where we're going to take some content. We'll pass in ID 5, some posted content, and let's run minimal API foo 5 and validate that the result that we get back is hello foo and 5. And so looks like I built that method a little bit differently this time. 1 and 2 is now saying 1 and 2 without an ID set. That's fine. So I have this now integration test of the post method. And if we wanted to fill that out, we could definitely do a test of the put method as well. But let's flip over to the test explorer. I can come here into the test menu and go to Windows and pop open the test explorer, and I'll get this, this window. So let's just go discover all of the tests in our project, and now let's run all of our tests. This is cool. Oh, all our tests went green. Excellent. We know our minimal API works, and we were able to validate it using these really elegant integration tests. Now, it didn't need to spin up a web server. It doesn't need to find an open port. All of this is in memory, but it's still flexing my entire request pipeline. That is cool. So testing in ASP.NET 6 is just so nice. So when we were looking at this minimal API, we kind of said, that's probably not the right size. That website was too big. Let's look at a minimal API that is probably a good fit for this. Now, minimal APIs nicely sit in between Azure Functions on one side and WebAPI on the other side. If I have a lot of content, I want to move towards WebAPI because now I've got controllers and I can have lots of things that auto-discover each other, and I don't need to have this big section in my program.cs that I'm merging all the time. So if I have a lot of stuff, WebAPI is perfect. If I just have one thing, Azure Functions is perfect because Azure Functions is just that one little function. What if I need a handful of things? So for example, I have this project where I just need to get this interesting config file online. Thank you to randomuser.me for this data. This isn't an actual user, but I have this JSON file and I just need to serve this from an endpoint. Oh, well, I'll just go reach into Node and do it. Well, now we can do this in .NET as well. So that's a really cool use case. So I do my builder equals web application builder.create builder. I'm going to add Swagger. I'll go read my text. Now I chose to put this inside of curly braces just so I couldn't cheat and go grab this text file later. But I'm actually deserializing this into a strongly typed class here in this record right here. So here's a record class that defines all of the properties in there all in one line, which is really elegant. So I've deserialized that into a strongly typed object. I'm going to stick it inside of dependency injection. And now I have this JSON file that I can pull in from IOC. So let's flip over to our request pipeline. In development, we'll show the exception page. We'll use Swagger and Swagger UI. In production, we'll grab our exception handler and we'll use certificate pinning. And then we'll map get and we'll inject this configuration file into our method from our IOC container. Now that's really cool. We could pull in an entity framework data context, or we could pull in a repository or another service. Anything we need to inject, we can just inject it into the method and it'll magically show up. So I'm going to return that as my result, and that will put that configuration online. Down at the bottom, I say app.run, and away it goes. So let's fire up this website and take a look at how this works. So we have this website, and we just want to be able to serve this interesting configuration file. We have Swagger here, which is really nice. So let's execute that method. And there's our JSON file served up from this web API, or from this minimal API. Now, with a website, even a microservice like this, we probably want things like error handling. So if we threw an exception in production, it would land on our error page. So yep, we've got error handling here in our application. We probably also want to do not found things. So let's go to not page here. And we have a 404 handle there, which is really elegant. And we probably also want to do health checks. So our application is now healthy. Now, how did we rig all of those pieces? Well, minimal APIs are really elegant at being able to map things. So here in our error handler, we said redirect uncaught exceptions to /error. So I'm just going to listen to /error and give you that results problem. Cool. At the end of this, I'm also going to map the bulk thing of anything we didn't handle so far and return to you a results.notfound. Now, the first time I did this, I actually had my method look like this, which, yeah, that's a little bit cleaner, but my page just kept saying empty page in browser, and I was like, is that a DNS thing? Is my server not running? And so I actually gave it a JSON object inside of my 404 page just so that I could help myself see it. Similarly, we wanted to grab health checks. So we just add health checks here, and then we map health checks to a particular URL. And now our microservice serves a JSON file. It handles exceptions nicely. It handles 404 pages nicely. It has a health check built into it. And it is the only file in our solution, the only C# file in our solution, and it's only 46 lines. This is the right size for minimal APIs. Smaller than what we need for a web API, but bigger than an Azure function, and we have all of the things that we need to be able to build a really elegant and robust microservice. This is probably that right size for a web API. For a minimal API. So that's in the right size folder. And I give it to you as a challenge to the reader. Add these unit tests in the same way that we built unit tests previously. You can reference the unit tests that we built in the chapter right before in chapter 9 here. And all of this code is now online at robrich.org/presentations or straight on GitHub. This was a lot of fun getting to show you minimal APIs. Any questions on minimal APIs? Excellent. Thank you for coming.